In this video, we're going to fully define the inverse of the function f of x equals x squared minus 6, where x is an element of negative infinity through to 0 included. So the first thing we're going to do is just quickly sketch this parabola. So it's a positive parabola which is translated 6 units in the negative y direction. So it's going to look something like this over its specified domain. So that point there is going to be 0, negative 6, and its x-intercept, if you were to do the calculation, should be negative root 6, comma 0. And of course, I've only drawn half of the parabola because it's over a restricted domain, negative infinity through to 0. What we need to do next is state the range of this function. So if we set up a little grid over here, and we look at f and the inverse of f for the domain and range, we have the domain of f is negative infinity through to 0 included, and the range goes from negative 6 through to infinity not included. And we know that for our inverse, the domain and range swap. So this becomes negative 6 to infinity, and this becomes negative infinity through to 0. So now we've got a lot of information about the domains and range of f and its inverse. We can now set out to find the rule of the inverse. So the first step that we're going to do is express our function in terms of y. So we're going to replace f of x with y, and in this case we're going to get y equals x squared minus 6. The next thing we're going to do is we're going to swap x and y to find the inverse. So when we do that, we get x is equal to y squared subtract 6. And now the third step in finding the inverse is to solve for y. So the first thing we're going to do to this equation is add 6 to both sides. So with that in mind, we're going to get y squared is equal to x plus 6. And then solving that, we get y is equal to plus or minus the square root of x plus 6. And now what we need to do is we need to determine which positive or negative square root graph corresponds to the inverse of the blue one that's drawn over on our right hand side. And the way we're going to do that is we're going to look at the range of the inverse. And it says it goes from negative infinity up until 0, which means we're going to take the negative square root graph. So the last step, which is step 4, is to express the inverse function using correct notation. So in this case, because it's f of x, we're going to use f inverse, which has the negative 1 above it, and state the rule, which is going to be the negative square root graph, x plus 6. And that's because we've referred back to the range of our inverse. We needed to go from negative infinity up to 0. And then we need to state the domain, which is going to be for x is an element of. And this time we're going to use this domain here, which we discovered at the very start was going to be negative 6 through to infinity not included. So here is the graph f and its inverse graphed on the same set of axes. And the last thing we're going to do is just show how we got to the point here where we said the intersection was at negative 2, 2. So to find the intersection between a graph and its inverse, we're lucky that we can solve the equation f of x equals x, and that's because we know that the intersection is going to lie upon that reflected axis there, y equals x. So if we substitute in, we have f of x, which is just x squared minus 6, is equal to x, and subtracting x from both sides, we find that x squared minus x minus 6 is equal to 0. And now this is a simple quadratic which we can factorise, so we look for the numbers that multiply together to give negative 6 and add together to give negative 1. So we have x minus 3 and x plus 2. And now continuing on, we use the null factor law and we say x minus 3 equals 0 or x plus 2 is equal to 0. Adding 3 to both sides of this equation will give x equals 3, and subtracting 2 from both sides of this equation will give x equals negative 2. And for our particular domain, x equals negative 2 is the correct answer, and because the intersection lies along the line y equals x, we know that the y coordinate is also negative 2.